Welcome back to Topic 39 for Algebra 1, multiplying polynomials, specifically a polynomial times a polynomial. In Part 3, we're going to practice solving a word problem involving polynomials. In this example, Miss Reed wants to frame her signed photograph of Taylor Swift. You can tell I created this. It is unfortunately not true, but hopefully one day it will be. The photo's length is 5 inches longer than its width, and the frame will be 2 inches wide on all sides. What is the area of the frame? So the area of the frame here is referring to this blue shaded section. Now before we get started, let's do cubes. So we're going to circle the numbers, 5 inches, and notice I'm also circling the units here because that's really important. And also 2 inches. Our question is, what is the area of the frame that we're underlining? And then we're going to box any important words that we see. The photo's length is 5 inches longer than the width, and the frame will be 2 inches wide on each side. And we want to find the area. For this example, do we know what the actual width of the photo is? It says the length is 5 inches longer than the width, but do we actually have a quantity or a measurement for the width? We do not. So here's where we have to use a variable. Let W equal the width of the photo. So on my graphic here, we're going to label the dimensions. So the width of the photo, I'm going to denote by W. Now the length is 5 inches longer. Since it's longer, we're dealing with addition. So we have W plus 5. Now because we're dealing with the entire area, we have to first think of what is the formula for the area of our shape here. Our shape's a rectangle. So area is length times width. So if we want the photo's area, we want to think about the dimensions, which in this case, our length is W plus 5, and our width is W. So this is our length times our width. Now we know the frame will be 2 inches wide on all sides. So that means from the bottom of the frame to the photo, that's 2 inches. From the top of the frame to the top of the photo to the top of the frame, goodness, that will also be 2 inches. From the far end of the frame to the left side of the photo, that will be 2 inches. And from the right side of the photo to the right side of the frame, that will also be 2 inches. So if we want the dimension of the entire frame, we have 2 plus, now we know this distance here is W plus 5. And then on the right-hand side, we also have another 2 inches. Now, if we combine our like terms, this is the same thing as 2 plus W plus 5 plus 2, which is W plus 9. For the width of this entire frame, we have 2 plus W plus 2, which gives us W plus 4. So for the frame's dimensions, or the total of the entire picture including the frame, we have W plus 9 for the length times W plus 4 for the width. Now in order to find the area of the frame, we need to do some subtraction. So we need to take the total area of this entire, let's do a different color, of this entire frame and subtract the area of our photo. That will give us, with the blue frame, what the area of that is. So we're going to take the total area of the frame and subtract the area of the photo. Here we can use the dimensions that we already identified in order to solve this. So the area of the frame is going to be the overall area, which is W plus 9 times W plus 4. Remember, length times width. Minus the area of the photo, which those dimensions are W plus 5, times W. Now what we need to do here is we need to simplify each quantity. So what I'm going to first do is to multiply. We have W times W, W times 4, 9 times W, and 9 times 4. So this is equivalent to W times W plus W times 4 plus 9 times W plus 9 times 4 minus, now on this side, remember, since multiplication is commutative, this W plus 5 times W is the same thing as W times W plus 5. So all we're going to do is just use the distributive property. We get W times W plus 5 times W. And again, since we're subtracting, we're going to subtract this entire quantity. Now let's go through and simplify each of the values. W times W, W to the first times W to the first is W squared. 4 times W is 4W. 9 times W is 9W. And 9 times 4 is 36. Then we're going to subtract. W times W is W squared. And 5 times W, which is 5W. Remember, when we're subtracting, we're really multiplying each value by a -1. So we have W squared. I can also combine my like terms here. 9W and 4W gives me 13W plus 36 minus W squared and minus 5W in this case. Now I can combine my like terms. I have W squared and negative W squared, and then I also have 13W and negative 5W. W squared minus W squared plus 13W minus 5W plus 36. Now W squared minus W squared, that leaves me with just 0. 13W minus 5W gives me 8W plus 36. So this is my final answer. The area, which is the shaded part, of the frame is 8W plus 36. Now here, again, since we're dealing with the area, we have to keep in mind our units. What we circled before is we're dealing with inches. Oops, as I just covered that. We're dealing with inches. So this is going to be 8W plus 36 inches. And again, since we're dealing with area, it's going to be inches squared. Area is the squared unit. And that is it. Thank you for watching topic 39 of Algebra 1, multiplying polynomials, specifically multiplying polynomial times a polynomial in a word problem.